So this is section 2.1.
What's it called?
It says calculus, the topic in our book. A preview of calculus. Basically, like it's trying to give you an idea why we're interested in all the stuff we're going to be covering, derivatives and integrations. So one of the things, so we're given this shape, and I want to find this area between them, between 1 and 2. Well, that won't be bad to find the area. Right? I hope that's not that bad. We can break it down to 2 sections. The first section, I can make it this shape and find the area for this, the blue shape here. And the other one is that little triangle that you see here. And I need the area of that triangle. So if you want to find the area there, okay, not bad. Well, I just need to know what the height of this. Well, since y equals to x, when x is 1, what's the y value here? 1. When x is 2, what's the y value? 2. So if I look at the blue area, what kind of a shape we have there? A rectangular shape. And what's the area for a rectangular shape? Isn't that length times width? What's the length from here to there? 1. And what's the height from here to there? 1. That's a 1. And what about the black shape here? BLK, black. I saved myself one letter there, you know. What's the area for that? That's what kind of a shape? So 1/2 base times height. 1/2 the base, which is what? 1, and the height, which is what? 1, that's 0.5. So what is the total area now? One plus 0.5, which is 1.5. Square units, whatever the units are, inches, millimeters, whatever we're using there. Okay. Well, intentionally I made the graph straightforward, simple. You have these beautiful shapes. Let me try another one. And I won't make it that difficult, but you still writing? Anyone still writing? No? Good. Let's say I have y equals x squared. Y equals x squared, what kind of a shape? Parabola, right? This is x squared. And let's say I want to find the area between 1 and 2. This is the 1, and this is the 2 here. I want to find that area between them. Now we got a problem. That's not a straight line. If I zoom in at that picture, because I made it bigger, it looks like this. This is the 1, this is the 2. So if you decide, well, let's find the rectangular one here, do a triangle. Well, triangle, that won't be a straight line. Notice if I cut it like this, and I found this area, and now if I run a line straight from that point to this point, I'm adding more stuff to it. If I calculate that black area, you can see we have an extra piece in it. That's not good. So then what are we going to do? Let's go back to that shape again. So it gets bigger every time I do it. We're going to do approximation of that. This is the 1 and this is the 2. And what about if I cut this into 4 pieces? Notice I get all, if I just do it as one piece, I get that little extra piece right here. See that little extra moon? If I make it a straight line, I'm adding all of that. And just add a big chunk to my area there. I don't want to do that. But what about if I cut this into 4 pieces now? There's 1, 2, 3, 4. 1, 2, 3, 4. And I can approximate this by making it a straight line. You can see I'm adding less area. Some people say, oh, that's a trapezoid. You know, area of a trapezoid. Remember, a trapezoid has a shape that looks like this. If we call this one A, we call this one B, we call this H. The area of a trapezoid is 1/2 A plus B times H. Probably wondering where that equation came from, huh? It looks complicated, doesn't it? But watch this. If you cut this into 2 triangles, what's the area of this triangle? The big one in the bottom. Isn't that 1/2 the base times the height? What's the base? B times the height. And what's the area of the top? That's also another triangle. It's 1/2 this base, which happens to be what? A times the height. And if you factor the 1/2 and the H out of both of them, you end up with that equation. That's where it came from. So if you want to get really a better answer, you break it down to trapezoid and you find the area of each trapezoid. But if you're like me and lazy, and our book does it too, you might say, I don't even want to use trapezoid. I'm going to break it down to rectangular shapes. So let's take a look at this. One more picture on the next page. I'll make it bigger again. I'm going to do it twice here. Remember, this is y equals x squared here, the equation for that. I'm going to do it twice. You'll see why I'm doing it twice. I'm going to break it down to 4 pieces. This is 1, equally spaced. And I'm going to use the highest point as my height. I'm going to treat this as a rectangular shape. Calculate this area. For this, I'm going to calculate that area. For this, I'm going to calculate this area. And for this, I'm going to use that area. And if I add them, that's an approximation of my area. But you can see in them what? I got some extra. You see that little piece? I got that piece, I got this piece, and I got that piece. So I'm adding to it. How about if I do it twice? You want to take a guess what the second time is going to be? What are we going to use for height? It's a smaller one. Well, this is even worse. I'm missing pieces here. This one I'm getting more, this one I'm getting less. So what do? Average them. If you average them, you'll be close to your answer. This is called the lower sum. We use lowercase. This is the upper sum. We use capital letters. So if I want to calculate actually the area here for both of them, I need to know the lower height. So this is y equals x squared. X is going from 1 to 2. If this is 1, this value here is what? 0.25, right? Oh, 1.25, sorry. And this is what? 1.5, the x value. And this is 1.75, and that's the 2, right? So what's the height here? We take the 1, plug it into x squared. What is 1 squared? That's 1. What's the height here? X is 1.25. What's 1.25 squared? 1.5625. This one. Is that 2.25 you squared it? 2.25. This one. 3.06. 06 you said?
Yeah.
And the last one is what? 4? So these numbers are the same for both of them. 4, 3.06, 4 there. That's the 3.06. I put it in the wrong place, right? There we go. I don't know why I use this point here. This is the 4 here. This is what? The 3.06? And this was what? 2.25. 3.06, 2.25. And this height, that's the bigger one we're using what for this height here? 1.56, 25. The higher end of it, you know. So when I calculate actually the lower sum, it's a rectangular shape. It's going to be the base of this, which is what? 0.25 times the lower height. The lower height here is what? 1. Plus the second piece, 0.25. And what's the height for the second piece? 1.5625. The next one, 0.25 times the height, which is what? 2.25. Plus the last one, which is 0.25 times 3.06. And if we see what the math is, 0.25 plus 0.25 times 1.5625 plus 0.25 times 2.25 plus 0.25 times 3.06. 1.968. 1.97 roughly. What's the upper sum? This is 0.25. And what's the height here? 1.5625. Plus the next piece right here. 0.25 times the height, which is what? 2.25. Plus 0.25 times the height here, which is 3.06. Plus the last piece, 0.25 times the height. And what's the height for the last one? 4? Is it 2.718 or 2.72?
Yeah.
And when you add them and divide by 2, small s, capital S, divide them by 2. 1.97 plus 2.72 divided by 2. You should be close to the answer.
2.345.
2.345. Now, my answer will be bigger if I picked actually more points. What do I mean by that? I'll enlarge the picture. One of them, it doesn't matter which one, just to show what I'm talking about. Made the picture really big now. We said 4 points. I keep making it level, but it doesn't really level here. Let me just make it a little bit nicer here. There we go. This is 1. This is the 2. That's the 4, right? Now what will happen initially if I do the upper height, watch what happens. I'm using this height for this box here. So I'm gaining all of that. I'm using this height for this. I'm gaining all of this. This one and this one. Instead of using 4 cuts, what about if I use 8 of them? 8. Let's cut each one in half. And we'll see if we're getting better at it. If our answer is getting closer to the real one. So the first box is going to be this. The second one is going to be that. So what did we lose by going to double the number? Didn't we lose this area right here from our answer? That's no longer part of the error now. It's gone. Notice this. If I use the upper height, this will be part of the answer before. Now it's going to be this one. I lost that piece too from my answer. This one. Now I lost this piece. And the last one. And I lost that piece. So these were errors before. Now we got rid of them. And guess what will happen if I cut it even more? Double that number. I get more and more accurate. Ideally, you want to go to where? How many cuts? Infinity. Ideally, but nobody's going to do that. When we get to chapter 5, you're going to say to find the area. I'm not going to cut it into pieces. I'm going to do something called the big S there. And we didn't even discuss that's calculus 2. That gives you the area there. And the answer to that, x to the 3rd over 3. Just got to trust me on this. 2 cubed, that's 8 over 3 minus 1 over 3. The correct answer, the exact answer, is 7 over 3. And what is 7 divided by 3? That's 2.3333. That's the exact answer to infinite cuts. So that's why we're looking at this. That's what calculus allows us to do. If you think this bottle was designed by mistake to be this tall and this wide, you're nuts. There's a reason for that. Company want to minimize the amount of plastic we use. Also want to make sure it's stable too. Because you can say, well, why don't you make the bottle really long, about a meter long or a yard long, and make it skinny? Good luck putting it on a table there. It will fall. So we have reasons for them. If you want to calculate the surface area of a shape, if you have like a salad bowl, and you want to, let's say you're into Hollywood, rich people, let me stop the video here.